Hey guys, welcome back to ITower. Today, we're diving into one of the most powerful and widely used design patterns in software development, the observer pattern. If you ever wondered how your favorite apps instantly update when something changes, how notifications work behind the scenes, or how different parts of an application stay synchronized without being tightly coupled together, you're about to find out. The observer pattern is the secret sauce that makes all of this possible, and by the end of this video, you'll know exactly how to implement it from scratch. This pattern is essential for any modern application. Whether working with reactive user interfaces, game event systems, notification services, or any app where multiple components need to know about state changes, the observer pattern is the go-to solution. We'll cover the theory behind it, walk through a complete implementation line by line, and test it together so you can see exactly how it works. You'll gain practical skills to implement publish-subscribe mechanisms, create loosely coupled architectures, and build systems where objects communicate without knowing about each other directly. This knowledge is crucial for modern frontend frameworks, backend event systems, and any scenario requiring reactive, scalable code. Before we dive into the topic, make sure to like the video if you're excited about this content, and don't forget to subscribe to the channel. It really helps the channel grow, and you'll stay up to date with all our tutorials. Alright, now let's dive deeper. The observer pattern is a behavioral design pattern defining a one-to-many dependency between objects. When one object, the subject, changes its state, all dependent objects, the observers, are automatically notified and updated. Think of it like subscribing to YouTube channel. When a new video is posted, all subscribers are notified automatically. The beauty of this pattern is the loose coupling it creates. The subject doesn't need to know what observers do with the information or their types. Observers don't need to know about each other. They just register with the subject and wait for updates. Using this pattern allows a data model to announce changes, while interested parties update automatically. Observers can be added or removed without touching the subject's code. This pattern is everywhere. Frontend frameworks like React and Vue use it for reactivity, browser event listeners are observers, and Node.js implements it via the event emitter. The mechanism is simple. The subject keeps a list of observers, provides methods to add or remove them, and a notify method that calls each observer's update method. Now let's build this pattern from scratch so you can see exactly how it works. We'll create a concrete example using a weather station scenario, where the weather station is our subject, and the various displays are our observers. First, we need to define what it means to be an observer. We'll create an observer interface that any observer must implement. This observer class acts as a base class or interface. The update method is what the subject will call, and the data parameter will hold the new information. We throw an error because this is an abstract method. It forces any class extending observer to create its own update method. Next, we need our subject class, the object that will be observed. In the subject's constructor, we initialize an empty observers array. This array will simply hold the list of all observer objects that are subscribed to this subject. Now, we need a method to let observers register themselves with the subject. The attach method lets an observer subscribe. We use an instance of check against the observer class to make sure the object being attached is a valid observer. That is, we check if it has an update method. If the check passes, we add it to our observers array. We also need a way for observers to unsubscribe if they no longer want notifications. The detach method unsubscribes an observer. We find the observer's position in the array by calling the index of method. If it's found, meaning the index is greater than -1, we call the splice method to remove it from the array. Now for the most important method, the one that notifies all observers. The notify method is the core of the pattern. It's called when the subject state changes. It simply loops through every observer in the observers array and calls their update method, passing along the new data. The subject doesn't know what the observers do with this data. This is loose coupling. Now let's create a concrete subject, a weather station. This is our concrete subject. It extends the subject class, so it inherits the attach, detach, and notify methods. We call super to initialize the observers array. Then we define the specific state for this subject, which includes temperature, humidity, and pressure. We need a method to update the weather measurements. This method updates the station state. After setting the new values, it crucially calls the notify method on itself. We pass an object with a new state to all registered observers. This is what triggers the update broadcast. Now, let's create concrete observer classes that will display the weather data in different ways. For our first concrete observer, it extends the observer class. In the constructor, we call super and store a name variable, just so we can identify this display in our console logs. Now we implement the required update method. When the weather station calls notify, this method is executed. It receives the data object and simply logs the current conditions to the console. In a real app, this is where you would update the UI. Let's create another type of observer to demonstrate that multiple different observers can watch the same subject. So we create a different type of observer. It also extends the observer class, but notice it maintains its own internal state, which is a temperatures array. This shows how observers can react to data differently. In this update method, we don't just display the data. Using the push method, we add the new temperature to our temperatures array. Then we calculate and display the average. This proves that two different observers can be subscribed to the same subject but perform completely different logic. Now let's move to testing and see this pattern in action. First we create our weather station subject. Now let's create some observer instances. Note that we have two current conditions display instances and one statistics display. This shows we can mix and match observer types. Next, we call the attach method on our weather station for all three observers. They are all now subscribed and ready to receive updates. We now call setMeasurements for the first time. This will trigger the notify method inside the station. As expected, all three observers receive the data and log their respective messages. We send a second update. Again, all three observers are notified. The statistics display now correctly calculates the new average based on its internal history. Now, we test the detach method. We pass in the mobile display observer. It will no longer receive updates. When we send the third update, only the two remaining observers, the current display and the stats display, react. The detached mobile display is silent, proving the detachment worked. So there you have it, a complete implementation of the observer pattern from scratch. We've built a subject class that maintains a list of observers and notifies them when its state changes. We've created multiple observer types that react to notifications in different ways. And we've tested everything to prove that the pattern works exactly as intended, with observers being able to attach and detach dynamically without affecting the subject or each other. In real-world development, you'll encounter this pattern constantly. When you add an event listener in JavaScript, you're using the observer pattern. When a React component re-renders because state changed, that's the observer pattern. When a database trigger fires, that's the observer pattern. Understanding this fundamental pattern helps you recognize these implementations in frameworks and libraries, and gives you the knowledge to build similar systems yourself. Whether you're working on front-end applications, backend services, game development, or mobile apps, this pattern is one of the essential tools in your developer toolkit. Thank you for watching. If you found this helpful and want more design pattern examples and programming tutorials, hit like and subscribe. See you in the next video.